All right, so I'm going to go over the quiz first. So if you want to just check as you go along, and if you wanted to jot down the correct answers, that way you had the solution, feel free. There were a decent amount of issues with number one. Just a couple folks thought you had to do some type of addition and subtraction or distribute the values in these two quantities. Basically, you just had to multiply everything together. So I just think some people overthought it a little bit. So you're just multiplying the integers. So you'd get negative 21. And then when you have the same base of an exponent, or same base of a quantity, and then you just had to add the exponents. So you'd end up getting a y to the negative 4, which would flip it down to the bottom of the fraction. And then again, we're just checking to make sure that you know the exponent rules for multiplication, and then raising an exponent to an exponent in this second one. So that's number one. Number two is fairly straightforward. Just write those numbers in scientific notation. So in the first one, if you're moving that decimal point to the right, that means your exponent's going to be negative because that's a really small number. And then if you're moving your exponent to the left, your exponent's going to be positive. And then number three, I just gave you two polynomials. I asked you to add them together and then subtract the second one from the first one. So that's pretty straightforward. You're just adding, when you have a variable raised to the same power, you can add those two quantities together. And then lastly was just making sure that you understood how to distribute when you're multiplying, and then also foil, but then also just understanding that you can raise a binomial to another power. That just means you're multiplying the binomial by itself. So are there any questions about this quiz? We're okay. One thing I'll point out is if you go through the homework for section, I think it was P2 and P3, you see that I'm not fooling you on these quizzes, right? These are, not super difficult problems, and they're just like the ones in the homework. So, when I'm assigning a homework, just try to determine the problem types from that homework assignment, and then that should help you study for the quiz and figure out what problem types that you're really good at that you don't have to focus on, and then focus on the ones that you're having trouble with. Okay? All right, so quiz one. There you go. So you had to submit a homework assignment to the Dropbox. So that was section P4's homework. And these were the numbers at the end of section P4. Does anyone have any questions about any of those homework problems? Yes? Sure. All right. So just as a reminder again, I'll just do any questions at the end of the same section in the notes. And also just a reminder, I wanted to show you here. If you go to that website, and if you're not in class for whatever reason, when you go to the content tab, there's a class notes link, right? And this just takes you to the exact notebook that I'm editing. So as I write in here, this thing's constantly being updated. So it has all the notes that I'm doing in class. And then also, again, we're recording every lecture as well. Just my screen. It's not recording you. So every lecture is being posted here. Now, it takes a while for these to upload. So by Thursday or Tuesday and Thursday afternoon, these things are up there. So if you're not in class for any reason, you're still going to be responsible for the announcements in class or, whatever we do. All right, so everything's on the D2L side if you're not here. Just wanted to remind everyone of that. Okay. So I already forgot the number. 73, did you say? Yeah. Okay, 73 is 20x to the fourth minus 5. Now this is in a section that says factor each polynomial using the difference of squares pattern. All right, so when you look at this, right off the bat, you can't take the square root of 20 and get an even integer, right? Or I should say a whole number, right? Same thing with 5. But can you factor something out? Is there a greatest common factor to these two? Yeah. Okay, so you wanted -5. What I'm going to do is, can I just factor out a +5? And I'll show you why I chose positive instead of negative. So I'm going to take out a 5. And then in order to get 20x to the fourth, I would do 4x to the fourth, right? And then I'm going to do minus 1. Now, the reason I kept the minus sign here is now I have the difference between two squares, right? You could take the square root of 4x to the fourth, right? And remember, what you could do when you have an integer and then some variable, you can always split them up if that helps you when you're thinking about this, how to do it. So the square root of 4 is 2, and then the square root of x to the fourth is x squared. And then obviously when you take the square root of 1, you get 1. All right, so when you could take the square root of the two numbers in a difference, right, and you get whole numbers, you could basically do this process, which was just this. So if you recognize that pattern, you put the first thing, like this term, this 4x to the fourth, when you take the square root of that, that goes out front in both areas. And then whatever the square root of the second term is, in this case 1, would go here and here, and then you just, doesn't matter which order you put the negative and plus sign. I could have had the plus 1 first, it doesn't matter. So then I think we're done at this point. There's nothing else you could do. So that should be your final answer. So do you see why I didn't take out a negative 5? Because I wanted to have that. Oh, okay, yeah. So you don't want to, did you say you divided the 5 out?
I took the 5 out, so I did negative 5.
Oh, okay.
Negative 4x plus 1, and then I didn't realize it.
Yeah, so this one, it was, this entire section was if you recognize that you have to take, if you see that there's two numbers. Now, if you ever saw this on a quiz or an exam, hopefully it would jump out at you, because the only types of problems where you have two quantities is the difference between two squares, right? So in this one, if you could just do it initially, like all these other problems in this section, you could just go ahead and do it right at the forefront. But this one, you had to take out a GCF first. So any other questions from, yeah?
63.
What's the number?
63.
63, sure. All right, 63. So we have 49x squared plus 42x plus 9. Okay, so this is in a section that says factor each polynomial as a perfect square, okay? So if you recognize, again, that, again, you could take the square root of 9 and get a 3. Same thing here. Square root of 49x squared, what would you get? 7x, okay? You could quickly find the solution to this, okay? So what you would do is basically take this answer. So you get 7x, right? Square root of that. That goes here. And then the 9 is 3. And then they would both be positive, right? Because you'd get 21x on the inside and then 21x on the outside, which would give you your 42x. And then your final answer would be this. Now, if you didn't see that, all right? If you didn't see that that was a possibility, you solve this just like we've solved any trinomial where we have three things. What you would do is you would take, and this one sucks, right? You have 49 and 9, right? So when you do 49 times 9, what do you get? So that's 50 times 9 would be what, 450? 450 minus, so 441, right? So again, you'd have to find out all of the factors of 441. So that stinks, right? But you could do it. You could work through that process and solve this just like any of the other trinomials. But if you could recognize that it's a perfect square, look how quick I did that problem, right? So if you recognize it, do it like that. Otherwise, you'll work through that same process. Yes?
45.
Did you say 45? Yeah, sorry. Sorry, these masters, it's hard to hear, you know? I'm trying to project my voice even more. Okay, so this is number 45. We have 2x squared plus x minus 36. All right, so another trinomial. This one, not a perfect square. So we have to go through the process. Now, I'm glad we're doing one of these because this is a good review. The process is the same for all of them. You take the coefficient in front of the x squared term, and then the c coefficient, the very last integer by itself, you multiply them together. So 2 times 36, you get 72. Okay? 72 is better than 441, so we can work with this. What are the factors of 72? Now, you could list them all out, and that's fine. But once you find one that can work in this problem, you're pretty much ready to go. So 9 and 8 is going to work here, right? Because the middle term is where all the action is going to come from at the beginning, right? Because what we're going to do is we're going to leave that first term the same. And what we're going to do is we're going to change that middle term to be 2 terms involving the factors of 72 that make the most sense. So I want to have this as a plus x, right? So I'm probably going to do plus 9x minus 8x, right? That's what I'm going to do with those. Now, the only thing is, in this problem, you want to put the, which one do you want to put with the 2? Because we're going to end up factor by grouping. I don't want to put the 9 with the 2 because I can't divide 2 into 9 evenly, right? So I'm going to put the negative x first, 8x first. All right, so I just changed the plus x into a negative 8x plus 9x, and then the minus 36 stays over there. All right, so that's, I guess, step 2. Step 1, right, was over here, figuring out the factors of 2 times 36. We'll call this step number 2, right, determining what to do with the factors, what signs do they have, and that sort of thing, and then put them in here. That's step number 3, right? I'm all about algorithms, right? I'm a physics guy. And then the last thing is factor by grouping, right? So this is a good review for that. So I put the 8x with the 2 because I know 2 can be divided into 8 evenly. So you look at the first grouping and then just find the GCF. So it would be a 2x, right? Right, the largest integer I can divide evenly between the 2 and the 8 is a 2, and then the lowest x power is x to the first, or just x. So then what's left? I have x minus 4, all right? Perfect. Now I go to the second grouping, and I factor it, find the GCF. It's going to be a plus 9, right? The lowest x degree, you might think, oh, it's x to the first, but really, you can think about this one that doesn't have an x as having x to the 0, which always evaluates to 1, right? So when one of the terms doesn't have an x, you can't factor an x out. So 9 is the largest that divides them evenly. And then when you factor by grouping, this is what you want to see. You want to see a factor, a binomial, that's the same, right, after you do a factor by grouping. All right, and then finally, the last thing you do is you take that same factor, the x minus 4, and then whatever's left, right, the 2x plus 9 goes in this second binomial. Now that process, you can solve every single trinomial you see here, even the ones that are factor each polynomial as a perfect square. It's just that the one that Terrence asked about was a big pain in the butt, right? Because I'm not finding all the factors of 441. And I would never do that to you on a quiz, right? I'm not going to give you a giant number like that as the last value. So does that make sense? Again, all the ones from 37 to, I don't know what the last number I assigned there, but they're all the same. This is the same process. Even the ones that only have, like, I won't solve it, but just to point it out, like in number 37, this x squared plus 7x plus 12, that one's probably pretty easy to figure out, right? Because remember, you could solve this the same way. What's the coefficient next to the x squared? Isn't it a 1? Right? So when you do 1 times 12, you're really just looking at the factors of this last value. But otherwise, it's the same process as this one. Although, if you got something like this, hopefully you would see that, well, all right, I know that has to be x, right? And factors of 12 are pretty easy to do, right? It's 4 and 3, 6 and 2. Oh, 4 and 3 add to 7. Well, it must be this, and every number's positive, and then boom, you're done. All right, so if you see some shortcuts, go for it. But you could do this problem just like we went through all these steps here. Okay. All right, anything else from this section? Are we all right? I can't see over there. We're okay. Who just came in? Was that Tommy? Or who? Are you were into the restroom? Sorry, I didn't realize if it was somebody who was already here. Good deal. All right, so there we go. So there's section P4, and we're going to move on now with section P5. Let's see, we'll go with, it's blue today. So this section is on rational expressions. Okay, so just as a review of what, the term rational means. So if you have a rational number, right, it would look like A over B. Okay, rational number, it just means a fraction, okay? A over B, where A and B are real numbers. Did you ever see the symbol for real is a big capital R with the big line next to it? So that just means reals. Where A and B are real, but B cannot equal 0. Because what happens if B equals 0? Is that allowed in a fraction? What do we term that if B is equal to 0? What do we say? The fraction is what? Or the rational number is, you remember it, undefined. Have you heard that before? When B is 0, the number is undefined. Okay? So that's just what a rational number looks like. Okay? So this section is a rational expression. So what's a rational? Remember, rational has the term ratio, right? Ratio is fraction. A rational expression is another term for a fraction is a quotient, right? When you're dividing one number through another. So a rational expression is a quotient. So it just means fraction of two polynomials. So instead of having just numbers where you say A and B in that fraction, we're just going to have polynomials. All right? Pretty simple. Yes? Oh, quotient. Yeah, sorry. My handwriting's not great. And then you should have seen what it was like when I first started taking notes on here, but now it's not terrible. So all we're going to do is in this section is look at fractions that have polynomials instead of numbers associated with them. And what we're going to want to do is we have to make sure that the denominator, right, so the term on the bottom of the fraction, we just have to make sure that's not going to be equal to 0. So in the problems, which is strange because I don't know, you've covered functions at some point in your life, but this section also wants you to define the domain of your rational expressions. And that would mean what values can you plug in for the variable x, because we're going to be dealing with rational expressions of one single variable. What values of that variable can you put into the rational expression to then get a real number as an output? Okay? And all we're going to have to do is look at the denominator of the rational expression. And I'm obviously going to show you a bunch of examples. Okay? All right, so the first thing that we want to do in this section, and again, this section, just like the others, I'm going to be showing you problem types, right? So you know what to look at. So this is problem type number 1. So this would be reducing. I'm just going to put RATEXP because I don't want to write that out. That's reducing rational expressions to lowest terms. So that's the first thing we're going to do in this little section here. And then the second thing is going to be finding the domain. And that'll actually be fairly simple. If we do this first part correctly, reducing rational expressions, finding the domain will be not so bad. Okay, so let me just give you your first rational expression, at least in this class. So here's the first example. So we're always going to have a fraction. All right, so there are two polynomials, right? The bottom is a trinomial. So technical, right? The bottom of the fraction. The denominator is a trinomial. And then the numerator is a binomial, right? So what we want to do is we want to reduce it to lowest terms, which means we need to factor both the numerator and the denominator. So all that section P4 was so that we could start doing this stuff, factoring these rational expressions. All right, so what we're going to do is we're just going to go down and factor each part of the fraction. So let's do the numerator. That's the easiest one. It's 2 terms. We're only going to be able to take a GCF. So the GCF of 3x and 6 is just 3. I'm hoping at this point everyone can find those. They should be fairly simple. So if I take a 3 out, I get x minus 2. Now, I just want to point out, when you have an integer like 3, or it could even just be any real number next to a quantity like x minus 2, remember that is really multiplication, right? You just don't see we just don't write that symbol, but that's really what we're doing. We're multiplying 3 times 3x minus 2. All right, how about the denominator? This is one of those trinomials that I'm most likely going to be able to put sort of the reverse FOIL method, right? This one's easy, right? We know this first term has to be x, because we're going to have x squared by itself with no other coefficient. And what factors of 4 can give you negative 4x? 2 and 2, right? So we know they're 2 and 2. And again, if you had to off to the side when you're solving a problem, go through the process from section P4, that's completely fine with me. Because again, more work equals more partial credit. And then what do the signs have to be to get the negative 4x in the middle? They both have to be negative. Okay. And again, when you have 2 quantities, you're really multiplying together, right? You're multiplying them together. Now, again, it's been a while since you've done stuff like this, right? If you had any fraction, let's just say with numbers and variables without having polynomials involved, and this was actually one on something like we did this on the quiz. If you had like 4 over x over 16x squared, right? What are you allowed to do, right? Since 4 times x and 16 times x squared, if there's something on top that could cancel out with the bottom, you can go ahead and do that, right? So a 4 and a 16, right? We want to reduce that fraction. Well, 4 goes into 16 evenly to get 4. So if I cross this out, I get a 1, and then the 16 becomes a 4, right? 4/16 is 1/4. So I've reduced that fraction. Now, what could you do with the variables? Well, this is x to the first, right? So what do you do with division? You would actually subtract the exponent, if you remember from section P, whatever it was, P2. Or you could just think about it this way. I have a single x up top, and how many x's do I have on the bottom? 2 of them, right? So I could cancel one of the x's up here and then just be left with 1 on the bottom. So my final result when I do this is just a 1, that's all that's left on top, over 4x. That's the same procedure we're going to do here with the polynomials. If you see a polynomial in the numerator and a polynomial in the denominator, you can cancel them out. Now, this is a great example to start with because I have 2 x minus 2's on the bottom. I can't cancel both out. I can only cancel one of them. So I'm going to cross off the one on top because there's only one there, and then an x minus 2 in the bottom. So then what am I left with? Well, I'm left with a 3 in the numerator, and then just a single x minus 2 in the denominator. Once you can no longer factor, and then you're done canceling out terms, you've reduced the rational expression. So that's one part of the final answer here would be, this is the reduced expression, 3 divided by x minus 2. And what that's also saying is that 3 divided by x minus 2 is exactly the same as this. They're the same expression. It's just easier to work with 3 divided by x minus 2 than having all that other stuff up there. Okay. Now, the second part, find the domain. Okay. So if this were a function, like say you wanted to graph this, right? You would have to know where is this function undefined. Okay. So all you do is you look at the bottom. I love saying bottom. The denominator. You look at the denominator, x minus 2, and you just have to determine what x values would make that 0. So how do you do that? You literally just take the denominator, so x minus 2, and set it equal to 0. And then solve that very simple equation for x. So you'd get x equals 2. So that means when you plug in, just look at it, when you plug a 2 into there, what do you get on the bottom? 0, right? So here's how you would express the domain. You could just do this like a D with a colon and just say, I remember domain is what values can you plug in. So you would just say all reals, right? So that would mean to me all real numbers. All reals except the one that makes you undefined, which is x equals 2. That's it. All reals except x equals 2. Now that's going to be important in some later sections when we're actually doing some graphing. Not bad? Yeah, pretty good. All right, let's do a couple more. Do a couple more just to see if they get any. I mean, that's the process though. That's going to be the same for all of them. So which one do I want to do now? Yeah, let's do this crazy looking one. And again, none of these are any different than things that you would have factored in section P4. All right, so look at that ugly looking thing. Like if somebody said, oh, why don't you graph that? You'd be like, nope, not going to do it. Because it looks crazy. You got a cubic function in the numerator, right? Cubic, x to the third, and then what would that be called? So it's cubic, and then I'm blanking. I don't know if that has a name. But x to the fourth, right? So that's a tough graph. But not if you reduce this to lowest term. So let's go ahead and factor it. So the top, I got two terms. It's not a difference. So I'm just looking for a GCF. So help me out. What's the GCF in the numerator? Yeah, x squared, right? We don't have an integer. We're really the integer's 1, but the lowest power of x is x squared. All right, so then when we factor that out, we're going to get a 3x and then plus 1, right? That's all. Then that's nothing else I could do up there. It's factored. All right, how about now you look at the bottom, that's a trinomial, right? But it's not in the form where you could use that process, right? That process I showed you to work through was basically for quadratics only. And that's only if you have x squared. Now, when you look at these three terms, there's definitely a GCF. Now, if you see a trinomial with a GCF, take that GCF out. Because what would it be in this problem? What's the GCF of the denominator? It's also x squared, right? And let's see what's left here. You'd have a 3x squared minus 11x minus 4. All right? Now, that trinomial that I just wrote out, we could use that process from section P4. Now, I don't know what a mathematician would say. They'd probably want you to keep that x squared all the way to the end. But what could you see you could do automatically right here? Yeah, get rid of those x squareds, right? And by get rid of, I mean you're canceling them out and then you're left with 1s, right? Every time you cancel something out, you get a 1. Okay, so they're gone. Makes the problem a little easier, and then you don't have to rewrite it every time. All right, so now, in the numerator, I have this 3x plus 1. I can't do anything. But now I have a trinomial that I can factor. So what I'm going to do is I'm going to go through the process again. So I'll do this off to the side. So for this trinomial, I need to factor it. So since I have a coefficient next to the x squared, I'm going to do that coefficient 3 times 4, and I get 12. Now I need the factors of 12. That could possibly give me an 11x, and I think I found it already. Right? 12 and 1 are going to do it. Now, how am I going to split negative 11x into 12 and 1? I would probably do this. Negative 12x plus 1. Would that give me 1x? Would that give me a negative 11x? Yeah, so that's how I'm going to split it up. So I'm going to do it all off to the side to keep the rational expression clean looking. So I'm going to have 3x squared, right? Remember that first term always comes down. Minus 12x. I'm going to want to keep the 12x with the 3 because I could divide the 3 out, or not divide, I could factor the 3 out evenly. And then do plus x minus 4. All right, now we're factored by grouping. So I factor this group first. So I'm going to take out a 3x and left with an x minus 4. Now, with this last grouping, can I factor anything with x minus 4? I can. Technically, I can't, right? Well, maybe not technically. procedurally I'm not going to, but can't I factor out a 1? So what I've been doing in these examples, when you can't do anything over here, is just do a plus 1 times that factor x minus 4. Because I like having that plus 1 there because that's going to show up in my final factored form. So I end up having the x minus 4 term. You'll notice that they're the same, so that's good, times the quantity 3x plus 1, right? I just take whatever was left over. Now I'm going to put that back into my rational expression in the denominator. So again, this is a section P4 thing, right? It's now factored, x minus 4 over 3x plus 1. All right, now you see there's a 3x plus 1 quantity in both the numerator and the denominator. Poof, they're gone. Now, that doesn't mean there's a 0 in the numerator. Don't get confused. That means there's a 1 here, right? So my final reduced expression is going to be 1 over x minus 4. Now, that's a rational expression I can work with. All right, so that's half of the answer. So now I want the domain. All right, so it's going to be all reals. I can plug all real numbers in for x, except what value? You probably don't even have to write that equation out for some of these. What would it be? Yeah, be 4, right? Except x equals 4, because when I plug a 4 in there, I get 0, which makes my rational expression undefined. So we don't like that. Okay. All right, I'm going to do one more of these. Yes, sir.
I did it different, like not really different, but I got the same answer.
What'd you do?
I just like looked at the denominator and saw that like back to 12, that's 11. I got 3x minus 12, 3x plus 1.
Oh, and then factored out a 3.
And then factor out 3.
That's perfectly fine, right? And that's fine because like some people have probably learned the process of factoring trinomials a different way, and I kind of want to go by the book, and I do like the book's way only because there's a little bit more work that you can show in the problem. And again, I like a lot of work, so I could give partial credit if something's wrong, but that's completely fine. If you can see what the factors are of 12 that make that work, and you just throw it in there and realize you could take out that 3 from that one binomial, that's fine. Yep, no problem. All right, more than one way to. There's bad terms about skinning cats, right? Ever hear that term before? You've never heard that term before? That's weird then that I said that. Yeah, but maybe that's a northeastern. You've heard that before. More than one way to skin a cat. Yeah, I don't know. Maybe that's a weird country thing up there. We live up in North Pocono. I don't know. Okay, one more. Now you learned a new expression. I bet you if you call your grandma or your parents, I bet you they'd heard that before. All right, one last example here. 3, and there's a reason I'm doing this one. 3x squared plus 2x minus 5 all over 9x squared minus 25. Okay. So, let's go through the process. Let's do the denominator first, because when you look at that denominator, what is it screaming out at you? Difference between squares, right? I think we might even have had that one in our homework. So like the square root of 9x squared would be 3x, so that goes out front. And then 25 is 5, and then it doesn't matter which ones you put plus or minus. So that one's done. We already noticed that. So then the top one, again, I got a 3 and a 5, so I'm going to do that's 3 times 5, or 15. Factors of 15, let's see, we need a 2x. It's probably 5 and 3, right? Seems like that's going to work. So what would I do? I would probably, to get a positive 2x, I'm going to do plus 5x minus 3x. I think that'll work. So we bring the 3x squared down. And then I'm not going to put the 5 with the 3x squared. I'm going to put the minus 3x first. And then plus 5x minus 5. Factor by grouping. I look at the first grouping. I could take out a 3x and get x minus 1. And then take out a 5 for the second grouping. And also have an x minus 1. And then the x minus 1 is the same, thankfully. And then I end up getting a 3x plus 5 as the other quantity. So that is the numerator factored. So I throw that in the numerator. Okay. And you could see that I could cancel out the 3x plus 5s and be left with x minus 1 over 3x minus 5. So that's my reduced expression. It's slightly more complicated than some of these other ones we've been looking at. So for the domain, the only thing that's a little different here is we're still all reals. Still all reals. And I just wanted to do this one because it comes up a couple times. It's not going to be a whole number for x. Like we've been dealing with whole numbers for a long time. So if you do 3x minus 5 equals 0 and then solve for x, you get 5/3. So you would say all reals except x equals 5/3. Unless you saw right away that if you plugged a 5/3 in there, you'd get 0. Right? So you could have a fraction as being the term that lets it be undefined. Now something else could happen. So let's say this happens. You do your whole process and you get, I don't even, so remember for domain, the numerator doesn't matter. So let's just say it's x minus 2. But this is what happens in the denominator. You get x plus 1, x plus 2, all right? Can't cancel anything out, right? But you have 2 terms in the denominator, right? So what does that mean for when you write your domain out? Yeah, there's just going to be 2 values that make the rational expression undefined. So again, it'd be all reals except which 2 values? You'd be x equals -1, because that would make the left polynomial 0, and x equals -2. All right, so just you could, when you're doing homework, that could be a possibility. Okay. Okay, so with that being said, we are going to have a quiz on Thursday. Okay. So here's what the quiz is on. I'm gonna put it in these notes here. So there's a quiz Thursday. Okay. It's on section P4. All right, so all of it. But also what we just did in section P5, which is just reducing rational expressions. And really, it's just more factoring, right? So then section P5, only reducing rational expressions. Okay? That'll be the Thursday quiz. And I'm going to do a solid for you right now, too. When you look at so the only type of problem you have to worry about for P5 are the ones we just did. All right, so they're the ones you have to look at. And I'm actually not going to assign you homework. Now, I could do this for you, too, if you wanted to practice some of those, for the quiz, because you could look at some of the odd answers. I could give you a couple of those. So let me you don't have to hand this in. This is just if you want more practice. All right, you could do reduce lowest term, specify the domain. So you could do 9 through 23 odd on page 58. So that's not something I'm going to collect because I really don't want you to focus on homework. But if you wanted practice with those, there you go. Okay? So you could do those. Now for P4, all right, let's list the problem types, right? Because this is how I think the best way to study for my quizzes and exams. What are the problem types? We have factoring. Well, they're all factoring. So factoring by GCF, right? I give you some type of polynomial. You'll notice that in each term I could take out some factors, and then the problem's done. Factor by GCF. What was the next thing we did? I think it was factor by grouping. Factor by grouping. Okay. Then there was factoring. I'm just going to say factoring by trinomials. And that's that process of taking the first coefficient in the polynomial times the last coefficient, like for a quadratic, doing that process. And then there were two special cases, right? We had factoring by difference between squares. We know how to pick those out. They might be the easiest of these, I think. And then the only other type that I mentioned that we went over were factoring by perfect squares. But you could factor the perfect squares by doing the trinomial method. So really, these two are linked because you could solve them using the same process. So if you don't notice when you look at a problem that it's a perfect square, you could always just go back to that trinomial method. So when you're studying for the quiz, this is it right here. Here are all the five. Is it five? There's really six if you include perfect squares, but really that and trinomials are the same. So there's, I'll say, 5 problem types total to study for this quiz. And you have all the homeworks to keep practicing, and none of the problems you're going to see on that quiz are going to be, any more complicated than what we've been doing. Okay, is that clear? So people who are going to watch this video, you will be also responsible for this quiz. So sorry, I'm going to talk to them because they're not here. Okay? Okay. So let's just keep going with section P5, but know that what we're going to do now is not going to be on the quiz. And again, this next part is fairly simple. Yeah, let's go. So all we did here was reduce these expressions. We had an expression, we reduced it. So now we want to do other things with rational expressions. We want to do other types of mathematical operations. Excuse me, I just want to take a quick drink here. Perfect. Okay, so let's start with the easiest of the ones. So I don't know if you think, well, adding and subtracting them might be easier, but that's actually more difficult. So let's just do multiplication and division. So we're going to multiply, and I'm going to try to use abbreviations here. Multiply and divide rational expressions. Okay. All right, so what does one of these look like? What I wanted to check real quick. Am I in the right section? Oh, sorry. Okay, good. I wanted to make sure the book's using the same notation as I am. So here's a very simple one. So i.e. Now these problems, for whatever reason too, they do not ask you for the domain in these, but you could easily do it once we're done at the end. But so we won't worry about domains for these ones. Here's a very simple example. I'm going to have 2 rational expressions. So I was looking in the book because I wanted to make sure they used the single dot as multiply instead of the X, right, or the multiply symbol there. So they use a dot. Okay. All right, so what we're going to want to do is let's factor everything that we can factor. Now, these are all pretty simple to factor. They're all GCF. So let's just keep doing them all. So 6x plus 4, the largest thing I can factor out evenly is a 2. So I have 2 times x plus, or 2 times 3x plus 2. I think I did that right, 6x plus 4. Okay. Let's do the denominator. Again, I'm going to factor out a 2 and be left with an x minus 4. And then times, so before I do any multiplying, I just factor. I can't factor the x minus 4, so I'll leave that alone. And then 9x plus 6, I can factor out a 3 and get 3x plus 2. Okay. So far, so good. Now, at this point, let's multiply these fractions. So what's the rules for multiplying fractions? Like if I had a over b times c over d, what would that result in? Anyone? Yes, sir. So for this one, you would cross multiply if you had this. Just as an aside, just want to make sure. Like if you had an equation, right? That's ringing a bell. If you have an equation like this, you would cross multiply to solve. But we're not even talking equations right now. If you have two fractions and you want to multiply them, you multiply the numerators together and then multiply the denominators together. So in my example over here, it's A times C over B times D, okay? Now, that rule still applies for polynomials. So what I'm going to do is I'm going to make one big fraction here, multiply the denominators, but I'm going to keep it in fact, multiply the numerator and denominator, but keep them in factored form. So I have 2 times 3x plus 2, and then I'm just really tossing that x minus 4 next to it, and then I'm doing the same thing with the denominator. Okay. Now, once you get to this point, now it's just reducing a single rational expression. So what can cancel out? The 2's, right? The x minus 4's, the 3x plus 2's, and what are we left with? 1 on the numerator, and then a 3 is snuck in right there. So we're left with 1/3. All right. So for multiplication, we're almost not even doing anything differently, right? It's still factoring them, and then just, you can think about it as just slapping the numerators together. Now, what you could do is if I look at right here, this line, since you know that, can't you also just start crossing off things on that line right here? So if you go from this line all the way to 1/3, that's completely fine as well. But I wanted to show you that if you wanted to make it look like one single rational expression, that might be easier for you to figure out what stuff can cancel and what can't. Okay? Easy. Do another one. And again, we're all just using the factoring things from P4. Okay. Let's factor away. So what are you seeing in the numerator of the first rational expression? Looks like a difference between squares. That would be correct, right? So you get, hopefully by now we're just kind of seeing those really quickly, and because it'll make your job easier when doing these. Okay. Now, again, if you're getting good at these, in the denominator, you might notice that, hey, I could take the square root of x squared end of 9, which means that you have x and then minus 3's here, right? So that's a perfect square. So you might see that, and again, that's going to make your life easier. But if you didn't, you go through, find the factors, and go through that same trinomial process. But that's what you would get in the denominator, and then you're multiplying it by, what do we have here? We're going to take a 5 out and left with an x minus 3 all over an x plus 3. All right, so what can cancel? Because really, couldn't I can just do this and go flunk, and that's the end. That's the next step. So what can cancel? Lots of stuff's going to cancel, right? How about these two x minus 3's go? This x plus 3 and that x plus 3 goes. And then another x minus 3 goes. And what are we left with? Just 5. Now, again, not a 0 in the denominator. There's still a 1 left over. So this is just 5. Now, will you always get whole numbers? No. It just happened that I got a 5 here and a 1 over 3. It could be more complicated, but these are just simple examples. Okay. So that's multiplication, right? There's nothing, I don't even think that's much different than what we just did. You just have two rational expressions. All right, so now let's do a division. Here we go. Here's a good one. We'll have to do a little bit of factoring on this one. All right, that's our divide symbol. Nope, I wanted to do... All right, so who remembers what to do with division? So again, off to the side here. If I had A over B divided by C over D, that was terrible divide. Does anyone remember the process? What do?
You flip C and D.
Yeah, so what would happen then? He's correct. You'd flip C and D, because then what happens to the divide symbol then? Yeah. So the divide problems just become the problems we just did. So here, we'll do that. And that's the first step here. I would say even before factoring, just get the divide out of there. So what I'm going to do is I'm going to flip the second rational expression and put the denominator as the numerator, and then the numerator as the denominator, and then change the operation to multiplication. Now this problem is just like the past two we've just done. Now we just got to go factor. So they're all trinomials. Let's see this first one. And again, hopefully you're going to see these and start getting really good at them and just know that this has to be x. And then look at the factors of 8. There's not that many of them. So 8 and 1 is not going to work. How about 4 and 2? Looks like 4 and 2 is going to work, right? Does everyone see that? So you have 4 and 2. And then how do you get a positive 2x there? The 4 has to be positive, and then the 2 has to be negative. Is everyone seeing that? And again, whichever, if you wanted to go through the process, that's fine. How about this bottom one? X has to be here. And what factors of 20 can give you a single x? 5 and 4. Now, let's see. To get a positive x, though, in the middle, we would have a plus 5x and then minus 4x, right? All right, multiplied. Now, what do you see in the numerator here? That's the difference between difference between squares. So it's xx, 4 plus minus. That one's easy. And then this new denominator one is also pretty easy. It's going to be 4 and 1, and I'm going to add them. All right, so lots of stuff cancels out here. So let's see. So again, this multiplication then just becomes, a big fraction here. Let's see. So I'm going to cross off these x plus 4s. How about this x minus 4 and that x minus 4? And I think that's it. So I'm left in this problem with several binomials. So I have in the numerator x plus 4, x minus 2, and then in the denominator x plus 5, x plus 1. So when you can't factor anymore and you can't cancel out things anymore, that's it. That's your final answer. Okay. How you feeling? Feeling all right? Not too bad? Okay. Any questions you have for me? We're okay? So I actually have an appointment that I have to go to at 9:45. So I'm going to let you out now. Okay? I'm not going to assign any homework aside from the problems I gave you at the beginning to try those rational expression reductions. But we'll run that quiz the same way we did last week. It'll be the last 20 minutes. Okay? Cool. All right, everyone. Have a great day. And hopefully your classes for the rest of the day are good. Sure. Let me just stop this recording here. so it's a little. At least I hope it recorded. Recording is recording.